the record. Let me just make sure it started. It started recording. So, all right, I'm recording this. I will upload this as well, but I think it'd be good for you to do the problems with me because I'm going to act like, like I'm on the final in the sense where you're not going to really know which section it comes from, except for the few that I want to like highlight. So, I want you to be able to do that on the final. You have to be able to look at the problem and go, all right, this is what it's asking me. This is the process. This is the topic. This is what I need for my reference sheet or whatever the heck, whatever works for you, right? Now, you guys have options for final review reference sheets. I have one here. I'll use it. I know that Dr. Tammy also posted one up, so you guys can look at both of them, pull what you need, like whatever works, okay? I'll use this one for my review. I think she used that one for her review. Do what you need. I didn't put the empirical rule on here, but I feel like that's something we've done so many times, but I could put it on there if we need it. So I have some particular questions that I think that, like there were mistakes made during the actual weeks. And then I know personally, I finished all my projects. I finished grading all my projects. So if you guys haven't checked that, check it. That overall final average now includes your extra credit if you did do extra credit. So that's where you're at. Whew, I thought I was going to sneeze. Excuse me. And then you are almost done. Okay, so I suggest that you do the final if you can do it tomorrow, if you feel ready. If not, prepare tomorrow, do it Wednesday if you can, but try to do it so that you're not waiting till the last minute, because if you do have something like your internet goes down or your computer goes down or whatever the heck might happen, that's not considered an extenuating circumstance. You're not going to be able to, you don't want a zero for that. You could take it, where is it? Let me go down here and talk about it real quick. It's not timed, just like the midterm, just like the quizzes. It's proctored with Honor Lock, and everybody will be checking every single video. So make sure you do things properly there because you don't want a zero for that. You have 3 attempts and the highest score is taken, just like the quizzes and the midterm. I think there's about 40 questions off the top of my head, approximately, just like the midterm, okay, similarly. And you could have a full sheet of reference, front and back. There's no restriction in terms of like written. I haven't seen anything related to it have to be written. So whatever, whatever works. Like I said, I don't know if I recorded this, but I have a review sheet that you can use to help create yours. And so does Dr. Tammy. She posted hers. So if you use one or the other or both, just to help you kind of like figure what you want out. And then one other thing, Friday this week is when everything is due, and you don't have until 11:59 like you usually do. You have until 5 p.m. Mountain Time. So, make sure that, like I said, you're not waiting till the last minute, because if you do the final, Wednesday, and you want to take it again, you have time to do that, right? So, don't wait until last minute. No, they don't have to be written. I said there's nothing that indicates that it has to be written. So if they're typed, they're typed. Anything that's indicated just says front and back, right? Yeah. All right. So any questions before I do some practice with you? Let me know if I forgot anything about like what, and then, there are no webinars this week, right? Technically, if we have them, it's just based on us wanting to like give you more practice. So there's no webinar access code. Okay. So it's not required for you to attend. And then what else? Let me know. I think the final is all you have this week. So like I said, we go through this tonight, see how you feel tomorrow. If you need to like review, try to do it tomorrow evening or Wednesday, depending. You don't want to wait too long after you review. And then if you need to take it again, you give yourself enough time to take it again. So you don't want to wait until last minute. So does that make sense? You guys have questions before I start some stuff? And I'm going to have you be interactive. That's my ultimate goal here, because I want you to recognize what the problem is stating rather than me just telling you, because your finals this week. So we'll work together on it, but I want you to think out loud. Even if you're wrong, think out loud, you know, type it up, whatever you need to do, like, so that we could figure this out together. Well, why is it that the situation that you think it is, or why is it not the situation that you think it is? Because remember that the final is mixed up. So you're going to have to look at the problem and determine what it's asking you for, rather than saying, okay, I'm in week 14. This is the topic. This is what I'm doing. Okay, so, all right. I'm going to start. Let me know if there's anything I forgot before I start. If not, okay. All right, so I'm going to have you mixing things up. I'm not going to tell you what it's from. And then we'll use my reference sheet to kind of determine, you know, maybe what it's from, see what you remember. So I have, let's see, suppose the heights of adult females are normally distributed. Now, you're going to have word problems, so you have no choice. It happens with these confidence intervals, hypothesis testing. So now it's just a matter of maybe reading it the first time to indicate what the situation is telling you, reading it the second time to pull whatever you need out, and then third time to verify or whatever. So, okay, I just turned my writing tablet off. Come on. All right, so suppose the heights of adult females are normally distributed with a mean of 180 and a standard deviation of 10. Find the probability that A1 randomly selected adult female has a height greater than 170. Does that sound familiar? Now, if you want to go, all right, let me look at my reference sheet. What is this? You know, like, is it a confidence interval? Is it a hypothesis test? Like, is it a sample size? Like, what is it? A correlation situation? You know, what does it sound like? What do you think? I want a probability. So I have a normally distributed situation. I have a mean and a standard deviation. I want a probability that a randomly selected adult female has a height greater than 170. I'll tell you what I'm thinking. It doesn't sound like a claim. I'll put it like that. So I'm not thinking hypothesis testing. I don't hear anything about approximating a population mean. So I'm not going to go confidence interval. It's focusing on means and standard deviation. So I'm not thinking about proportions. This is my thought process, okay? If I look over here, I'm not dealing with a minimum sample size because it doesn't say anything about like what is the, you know, amount of people that I need. I like empirical rule is closer, but that is restricted to whether or not I'm, you know, 1, 2, or 3 standard deviations away from the mean. And I could try that and see if it works. But I think I'm going to go more so with what you're saying. I'll draw a normal distribution curve. Okay, I'm normally distributed. And if you think about it, this is a population mean that is given because it says the heights of adult females in general, like all of them. And then the standard deviation is 10. If you recall, the center of these curves is the mean. Now, why am I doing that? When I hear probability, I'm thinking what? I'm thinking week 8. I'm thinking I want a probability. I want an area. So this is how I think. This is if I want an area, then I'm going to go and look for normal CDF. So I want to see the area that I want. All right. So I'm focusing on this value here, 170, which is, you know, obviously to the left. And I want to determine a probability of more than that. The probability implies area. And I see typing. I know that sometimes I think my chat is a little delayed, but I'm thinking area to the right of that. Are you with me? And again, like if it's something that you were not thinking, think about, well, why? Well, why is it now this? What makes us figure this out? Well, it's normally distributed. They tell me a mean and standard deviation. They're asking for a probability. I don't hear anything about a claim. I don't hear anything about a p-value. I don't hear anything about like approximate an interval. I don't hear anything about a critical value. I hear nothing about like, tell me a minimum sample size. It's got to be, you know, week 8 where I'm finding an area. And if the empirical rule works, then it's the empirical rule, right? Okay, so she's saying 1 standard deviation above is 190 and 1 standard deviation below is 170. So we could use the empirical rule. Find the empirical rule would work. And if you recall, and I'm probably not going to use that, but within 1 standard deviation, we have approximately 68%. And then within 2 standard deviations, if I were to find 2, we have approximately 95%. And if we are within 3 standard deviations of the mean with the empirical rule, we have approximately 99.7%. And we could really break this down even further, right? If you recall the empirical rule, you know, like if I need to go further than that, which I might want to because of the fact that I want to know everything bigger than this, if you recall, and you could literally have the area and the curve in front of you, you know, you split 68% into 2 pieces, approximately 34, 34, right? We can keep going. Do you guys remember what's in these little areas between the 1st and the 2nd standard deviation of the mean, above the mean? If I don't recall, you can have the curve in front of you, 95 minus 68. I'm probably going to use normal CDF, but I'm going to show you how both of them can give me a similar kind of output. Okay. And then if I'm still going, 1, 2, and 3, 99.7. Now, if you're using the normal CDF, what are you guys getting? 2.35. And then this is approximately 0.15. So I can, you know, I can add up all these, you know, areas to the right of 170. I want you to tell me what you get. And then if you're using normal CDF, what do we get? Because remember, normal CDF gives me area on a normal distribution curve. So technically, the empirical rule and normal CDF kind of go hand in hand. It's just that the empirical rule is more limited, right? So if I'm using normal CDF, do you guys remember how to bound it? We lower bound, upper bound, mean, and standard deviation. Some of you, if you go to second VARS, normal CDF, it asks me for lower, upper, mean, and standard deviation. So what would be my lower bound if I'm using normal CDF here? And I don't care if you come off mute too. And I see typing. Yeah. And then my upper bound would be, yeah, positive 1E99, right? Because I'm going to the right all the way to infinity. So my upper would be that positive 1E99. I would use negative only when it's less or the lower. And then my mean is 180. And my standard deviation is 10. And oops, I have an extra thing here that I don't need. And what do we get? Mean is 180, standard deviation is 10, approximately 0.8413, depending on how we're asked around, right? If I were using the empirical rule, I could technically add up all these areas to the right. 34 plus 34 plus 13.5 plus 2.35 plus 0.15, approximately 84. I mean, if you think about it, technically, normal CDF is more accurate than the empirical rule. However, you might be asked to use the empirical rule. But I wanted you to see that they both kind of go hand in hand. They're not really separated. Empirical rule is just kind of like specific to those locations. You got 0.15. It should be. I'm going to tell you something to indicate that my probability is also looking proper. So half of this area is 50%, right? And if you think about it, if I move this a little bit to the left of the center, which is always the mean, I'm getting more than 50% of the area. So I'm expecting my probability to be greater than 50% or greater than 0.5 if I'm trying to figure out if the area that I got makes sense. So Angela, possibly second VARS normal CDF, let's check it. My lower is 170, I'm bounding that area. My lower value is here. I want greater than that, so my upper value is positive infinity, which is that positive 1E99. And by the way, you could literally put a large, has to be a large positive number. Make sure you change your mean and your standard deviation for this case to whatever's given. In this case, 180 for the mean, 10 for the standard deviation. And then try it again. Make sure you get the same number. Does that make sense? So this goes hand in hand with the empirical rule with normal CDF, because what does that mean? Can you hear me again? I just heard like a hanging up and then a coming back. I don't know if my computer just like hung up and came back. Let me know if you can hear me. Because if we are 1, 2, and 3 standard deviations, thank you. If we are 1, 2, and 3 standard deviations from the mean, we can use the empirical rule. But if we're not, then we have to go to normal CDF, okay? So I want you to recognize that. Okay, let's look at this. I'm going to do more than the question asked, but let's look at this and try to determine what it's asking me for. And how do I determine that I use what I'm going to use, right? So I have the student test scores for a nationwide standardized test have an unknown distribution with a mean of 259 and a standard deviation of 38. Now this is nationwide, right? So this looks like a population mean and a population standard deviation. So I'm using the notation that I know goes with that, right? A sample, I'm given a sample with size n is 55. Let's see what I'm doing with this sample. Was randomly drawn from the population. I mean, this is an indication. Use the central limit theorem for means. What is the mean for the sample mean distribution? What is the mean for the sample mean distribution? So it does indicate the central limit theorem. So let's look at that. Can you see this? Is this big enough? So I have the central limit theorem here. And if you guys recall how I taught this, whenever you have this notation with, your X and the squiggly line and then the end, you always have the type of distribution is normal with the mean and the standard deviation. That's the order in which it comes. If I'm using the central limit theorem, depending on what I'm asked for, if I'm asked for the mean of the sampling distribution of sample means or the standard deviation, in this case, the mean for sample mean distribution, I'm looking for this, and then I'm going to actually find this as well. So what is the mean and standard deviation, just in case, because you could be asked for either one. So literally like plug and chug, put it like that. So whenever I'm trying to use the central limit theorem, the mean of the sample mean distribution is always the same as the mean or population mean given to me. So this is an easy question. I don't have to really do anything. So when I'm applying the central limit theorem for means, it is basically what's given to me. The mean of the sampling distribution of mean, right? Or the mean for the sample mean distribution. It's the standard deviation for the sample mean distribution or the standard error that you have to do a little bit of work. Not a lot. This is all you have to do. All you have to do is take your standard deviation that's given to you and divide by the square root of n. And on my calculator, 38 divided by the square root of 55, and then, follow what it says to round, 5.124. We'll round to 3. Okay, I did a little bit more than this question asked because I found the mean and the standard deviation just in case. And if you see this notation, that's what it's asking for. So let me know if that makes sense, how I identify what I'm doing for this situation, right? How do I know that this is what I want to do? Questions? Are we cool? We okay so far? Does this come back? Is this coming back from back in the good old days? Week 8 stuff. Now, again, I'm mixing this up because I want you to be able to look at it and go, okay, this is that, because it's going to be like that on the final, right? Okay. I also want you to see the questions where you're like, yo, hell yeah, give me that question. That's a giveaway. Let me do that. Takes me, 10. I want you to be able to identify those as well. Like this one. I'm going to read this. I don't know where it's from. A researcher is trying to estimate the population mean. Whenever I hear estimate a population mean, you could probably assume you're going to do a confidence interval or something related to that. The sample mean is, this is a little typo, X bar is 45. And the margin of error they gave to me is 9. Oh, find the confidence interval? Well, thank you. I mean, you don't really have to do, actually, you don't really have to do much, right? Your confidence interval is always the point estimate minus the margin of error and the point estimate plus the margin of error. And in this case, I'm estimating a population mean. So we have 45 minus 9 and 45 plus 9. I'm not even going to finish that. You guys tell me if that makes sense or if you have any questions. Again, I'm playing around here. I'm bouncing around. I want to see if you can identify the question and what it's asking you for. Stop me at any time, okay? Suppose the number of hours employees work in a week in a company are normally distributed with an unknown population mean. I hear unknown population mean, I'm probably thinking something related to a confidence interval, because if the population mean is unknown, we might be wanting to estimate that. Population standard deviation is given to me. Sigma is given to me. This is important because it could indicate whether I use T versus V. A random sample of employees' weekly hours produces a sample mean of, I'm given a sample mean. And if they didn't give it to me in the notation, I would convert it into the notation, right? Now, I might actually, I don't know if you guys can hear my kids, but I might have to make them quiet. Can you hear them? They're so loud. Hold on. Hey, into your room, please. You're making too much noise. Thank you. Okay. They're literally outside my door. Okay. So let's see. Use a calculator to find a value of Z that should be used to calculate a confidence interval. Now, am I actually finding the confidence interval? Or am I just determining the critical value for the confidence interval? Like, what am I finding here? Because I see sometimes there's misunderstandings or mixing things up. What am I trying to find? You want a value of Z. You want a critical value, but for a confidence interval. And we approach the critical values for the confidence intervals differently than we do the hypothesis testing, right? So I have a 90% confidence level. I mean, I want you guys to, tell me what to do here. Now, if you, if you followed my webinars, I did this. I drew a normally distributed curve, which they tell me, and I know it's standard because technically sigma is known. And when we're doing a confidence interval, I said, well, the center here, that area is what? What is the area of that shaded region? And I'm drawing this because my critical value is going to be this value here. This is the critical value. This is the Z-score that I want for a confidence interval. Always the positive one. What's that middle area? See, I'm getting different things. So I'll tell you this, okay? That middle area is not the rejection region. I'm not even thinking about hypothesis testing. The rejection region, I always think about hypothesis testing. I'm not even thinking about that. I'm drawing this curve because I want to determine a critical value. Now I'm showing you, yeah, and I'm showing you what it looks like to find the critical value when you're dealing with a confidence interval, but that center area is your confidence level, that 90%. And why do I need that? If I want this critical value, and I have this here in such a way, if I want to determine a critical value, I'm going to use inverse norm, but I need to know the area, right? So I know that everybody had different things on their calculator, but if 90% is in the middle, then the leftover has to be in the ends, 10%, half of it here, and half of it here. Remember, we did that, and I want this value that is located here. It's a z-score, which I use inverse norm to find. Now, when I go to inverse norm, question or no? Some of you had left, center, right. Some of you had left, right. Some of you had nothing. Like, I know that there were different scenarios. If you have the option to tell it left, center, or right, I'm going to tell it that the area of 0.9 is in the center. I'm going to keep the mean and standard deviation as 0 and 1. And the reason is because when I want a z-score, it is always going to be that, correct? It's standard normal distribution. Thank you. You remember. So the mean is 0, standard deviation is 1 when I'm dealing with just this curve talking about z-scores, right? And then I'm going to tell it that the area is in the center. So I don't know if anyone has found the z-score here yet, but let me know what you get. Do it with me. Okay. Now I did it where, I can tell it center, but some of you didn't have that option. So whatever option you're doing, I know that there were different cases. What do you get for this critical value? Do it on your calculator. It's good to do it. So if you're not doing it, if you don't have a calculator, grab it. Not hearing or seeing anything.
Don't we get 2 because it's in the center? So it'd be negative 1.645 if you want 3 digits, or it'll be positive that as well.
I'm only taking the positive one because of the z-score for a confidence interval. If it were hypothesis testing, then I would maybe think about whether it's negative, positive, or both. But because it's a confidence interval, we always take a single positive z-score.
So then it would be 1.645.
Awesome. Can I remind you what it normally is? You mean, what do you mean by that? Which area? Oh. Yeah, if you don't have the option, you mean like if you don't have the option of telling it left, center, or right. Yeah, if you don't have the option of telling it the location, then the calculator is automatically assuming left, and you would put 0.95. If you don't have the option, because you have to basically tell it all the area to the left of the value that you want. But you would get the same thing. Yeah, good question. Because I know, like, we had like all 3 cases. You guys had options to say all 3, options to say 2, options to say none. It was like weird. So Angela, if you got negative, is maybe because of the fact that maybe you did the 0.05, you got the negative version. It would be the same value because it's symmetric. So you could just make that positive, but you have to know when to make it positive, when to make it, you know what I mean? You have to pay attention to that. Because when we're dealing with confidence intervals, it's always a positive z value or t value depending, right? But it's always the positive one. When I'm doing hypothesis testing, that may change. You're not tripping, Hannah. It would be the same because of the fact that it's a standard normal distribution curve. So you could technically write down critical values for 90% confidence interval, 95, 99. Those are the typical ones that you see often, which would be the same if it's always a z-score. So you're not tripping. You're actually looking at patterns, finding, repetition, which is repetition. Left, yeah, the values in the left side of the center of a standard normal distribution curve are negative, and then to the right are positive z-scores. What do you think? Question. Let's find one where we have to do the stuff. Okay. Let me find where we have to do it. Bounce around a little bit. Let's see. Okay. Okay. Now, I'm going to find all the pieces when it comes to some of these, but remember, you could be asked for any part of. So for example, what I mean by that is this one. A random sample of 13 teenagers were surveyed for a hypothesis test. A hypothesis test about the mean. You know what that tells me? I'm going to run a hypothesis test. Every time I think about a hypothesis test, I'm always writing down a null and alternative hypothesis. And you guys have to think, well, is it mu or is it p? You only have those two options. And because it's a hypothesis test about the mean, we know that mu is going to be on this. And you have to practice writing your null and alternative hypothesis because that is something that you'll be asked to do, right? Okay, that means I'm looking for a claim. And let's see what else I want. Researchers conduct a one-mean hypothesis test at the 1% significance level. I might need that. I might make up some numbers for this too if I'm missing some. To test whether the average spent per week on convenience goods is greater than $50. So, couple of things. One, you might be asked to write down your claim or multiple choice. Pick down which one is the claim. Pick which one is the claim. So you have to be able to identify the claim in words. So I'm going to start there. What is my claim in words? Well, I'm definitely thinking hypothesis test because I'm testing a claim. I'm testing something, right? They tell me it's a hypothesis test. Even if they didn't, I'm thinking hypothesis test. What is it about? It's about a mean because it's talking about average. What is the claim now? I got to find the claim in words. I got to convert that into my notation for null and alternative hypothesis. So my claim, test whether the average spent per week, I forgot per, on convenience goods, I'm just going to put convenience, blah, 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 goods, is greater than $50. It's literally in the problem. You almost have to just not copy and paste, but pick the one that matches, right? Which tells me that my alternative is greater than 50, and my null is equal to. Now, remember that there are possibilities that with the null hypothesis, it could really just say equal to, or it can say, whatever's not in the alternative, in this case, less than or equal to. But the null hypothesis is always carrying the equal to. So if you ever have multiple choice, if you see an equal to on your alternative, that's automatically eliminated. So I identified it as a hypothesis test. I identified it as, I identified the claim. I'm able to convert it into null and alternative hypothesis. And then what kind of test is it? It's a right-tailed test. I need to know that too. Now I'm probably going to find a few things here. Let me see what other examples I have just to make sure. But I'm probably going to do a few things here because I want to practice all of these things. I want to practice critical value, p-value, test statistic, and I want to practice, conclusion, and I want to practice interpretation. So, I'm going to start with the critical value. If I were asked for that, I'm going to make up some I'm going to make up a couple things. I'm just going to say the sample mean, like they don't give it to me, but I'm going to make it up for now just because of the fact that I don't have it here. Okay. We'll say the sample mean of this, is $48. Assume you're given that, right? All right, let's run this test. Let's start with the critical value. Critical value. Now, I always draw my curve. It helps me. But now I want to hear talk about rejection region. I want to hear talk about a rejection region because of the fact that I'm dealing with a hypothesis test. Where is my rejection region and how much is the area of the rejection region? So you can type or you can even come off mute. Okay, I see 0.01.
The alpha?
Yes, the alpha. Where is it? Where do I put it?
On the right side?
On the right. How do you know?
Because it's a right tail test.
Yeah, it's a right tail test, points to the right. The area is not, so be careful. It's not 0.01%. It's technically 1%, which is written as 0.01 in decimal form, right? And the critical value would be here. So this is a situation where my critical value has to be positive. If this were a left-tailed test, my critical value would have to be negative, right? Because it's a hypothesis test. I'm following the type of test based on the alternative hypothesis. So, the thing about this is also, if I'm dealing with a hypothesis test, right? I have 3 different scenarios that I have to worry about. Is it a proportion? Is it a mean? Is sigma known? Is sigma unknown? I have to think about that stuff. And if I'm dealing with a critical value, sometimes you might have to use T's. So the thing is, it's a hypothesis test about a mean. So I know it's either this situation, the second or the third. Well, is sigma known or is sigma unknown? What is sigma? Sigma is the population standard deviation. Do they tell me anything about a population standard deviation? Even if they give me a standard deviation, you have to determine if it's from the sample or the population. There's no population standard deviation. Sigma is unknown, which means that I'm on a student T distribution here, and my critical value is going to be a T-score. Those of you that are in my class, I wanted to see that kind of stuff on the project too. Like if you gave me a critical value, is it T, is it Z? I want to know, right? So, in this case, inverse T, area. So inverse T, you see how it doesn't ask me like the location of the area? I don't have the option to say, this is the area to the right, this is the area to the left. I don't have that option. So your calculator has, you have to tell your calculator that it is the area to the left. It's always going to do area to the left. Let me just make sure. Oh, see, I knew. Rose, are you in here? Hold on 1 second. I'm seeing a couple people that trying to be in and not in. So but as I do that, what do you think? What's that area to the left? Mm-hmm. 0.99. Because, if the whole thing is 100% or 1, take away this, you're left with the 0.99. So that area that I'm putting here is 0.99, right? What about DF? I need that, right? I need that when I'm dealing with T-scores. DF is always 1 less. Yeah, cool. So my degrees of freedom were 12. Does this sound familiar? So my critical value here, if I need a critical T-score, in this case, 2.681, just, in case, they ask me for it, Now, stop me if you have questions, but I want a test statistic and I want a p-value and I want to actually come to the conclusion and all of that stuff because you could be asked for any part of this, right? The idea is that you could be asked for any part of this. You could be asked for the claim. You could be asked for the null, the alternative. What kind of test? What is the critical value? Be asked for the test statistic, p-value, interpretation, all these things. You're not going to be asked for all of it in one shot, but I want you to understand that, any one of them is fair game for any problem. So what do you use for your test statistic? If you use this, right? if you're doing a hypothesis test and you want a test statistic and a p-value, it's either going to be a z-test or a t-test. And because we said sigma was unknown, is going to be t-test. So we're going to go stat, test, t-test. Do I do data or stats?
Stats, right? Because data is your list.
Mm-hmm. So I would use data if I had a list of values. I don't. I'm given statistical values here, right? The first thing that I'm given is always what's on the null, which, you know, or the alternative, 50. X bar, you're given that. Sample mean is 48. I gave it to you in this case. And notice that when I'm doing t-test, they ask for X instead of sigma. And that is an indication that you're using T when sigma's unknown. You could be given a standard deviation, but you have to say, is it sample or is it population? Okay, in this case, let's say you're given the sample standard deviation is 15. The sample size is 13. You have to tell it what kind of test is it. You have to tell it it's a right-tailed test because that's going to affect your p-value. I think that some of you had errors with that when we were doing that, and I don't know, whatever week it was, because I think you were forgetting to tell the calculator what type of test. You have to tell it right, you have to tell it left, and then use your arrow to go down to calculate instead of pressing enter, okay? Because I think somebody said that, you know, they're pressing enter and they accidentally change the type of test as they're going through like that. So I have my t, which is negative 0.48, a huge p-value, 6803. And then I want you guys to tell me, what is your conclusion? It's the fun stuff, right? Now we're going to actually do the conclusion, interpretation. You know, at least you won't have to write it yourself. You just have to pick which one matches. But if you could write it yourself, then I think you can pick which one matches, right? So you, let's say using the p-value method, right? And I think, let me see if I have this. I should have this here if you forget it. Okay, in the p-value method, yeah, you have to determine whether the p-value is less than or equal to alpha or if it's greater than, right? So in this case, our p-value is 0.68, and you're always, this is something else that I saw, and I'm just, you're comparing it to alpha. I saw some comparing it to other numbers. I'm not sure where this was gotten from, if that makes sense. Your p-value is greater than alpha. And I'm going to write this because I want you to know that you're comparing the p-value that you just found of 0.6803 to alpha 0.0. I saw some, and I saw this on the project, you know, and I see you guys, you got the answers. But comparing the p-value to all these other random like numbers, and I'm not sure where that comes from. You're comparing your p-value to your alpha. Alpha is always given to you. So, you know, be careful too with your zeros and such, because I saw mistakes there. You know, like how do you compare decimals as well? You know, if you're looking to the right of the decimal place, whichever one has the larger number, in this case, 0.6, whatever is bigger than 0.0, whatever. So p-value is bigger than alpha, and what you guys said. We fail to reject the null hypothesis, right? Fail to reject the null hypothesis, not just anything, the null hypothesis, particularly. And I think, do I even have that here? Yeah. So if I'm failing to reject the null, there is insufficient evidence, or we're not supporting the alternative. I know there's like, the verbiage is like all funky and people are like, I don't know, you know, but if you need to write this down, write it down. I fail to reject the null. I'm not supporting the alternative. Insufficient evidence. We're not supporting the alternative. Okay. And then literally there is insufficient evidence to support the claim that literally the alternative, the average, okay, I'm not going to type all that, average spent per week is greater than 50, right? $50 or something. Right. You remember that this is multiple choice for you as well. You have to identify, the one that matches. And sometimes you could literally change this to sufficient or like not supporting or supporting. And then this could be changed. You have to pay attention to those little details. And again, when you're failing to reject, we're always talking about the alternative with the interpretation. So if this part doesn't match the alternative when you're interpreting your conclusion, then something is wrong. No, the p-value is for every single anything. P-value method is used for any hypothesis test. It just so happens that this one is right-tailed as well. It could be left-tailed. It's always this. These symbols will not change, okay? Even if it's left-tailed, if the p-value is bigger than alpha, we still fail to reject the null hypothesis. It doesn't matter what kind of test it is if we're using the p-value method, which is sometimes why it's preferred, because if you get the p-value, boom, you're basically done. You can come to your conclusion. Does that make sense? Ask me more questions about this, because I could do another one, but I want to make sure you got this, because I know there's a lot of pieces. And I saw some confusion even on some of the projects or some of the quizzes. Even in the stat chat and stuff. So you might be, no, p-value method is for anything. But I don't want you to confuse it with, like the traditional method, right? The traditional method is dependent on the type of test, meaning when I'm thinking about the traditional method, hold on, I don't want to change that. When I'm thinking about the traditional method, I'm thinking about the test statistic in the rejection region. And in this case, the test statistic is like to the left here somewhere. It's not in the rejection region. So you might hear something like using the traditional method, since the test statistic is less than the critical value, which I'll put, what is this, 2.681, and the test statistic was negative 0.48. We failed to reject the null. However, you got to be careful with that one, because, this depends on the type of test. What I mean by that is, if this were left-tailed, for example, and I said the test statistic is less than the critical value, that one I would reject the null. And the reason is because if it's a left-tailed test, I'm gonna have to erase it. If it's a left-tailed test, the rejection region is to the left of the critical value, and I would want my test statistic in that region to reject the null. When the test, yeah, so this is the repetitiveness. Repetition is a more accurate word. Like, period. If you're rejecting the null, there is always sufficient evidence to support the alternative. Period. Reject the null, support alternative. Doesn't matter what kind of test. If we fail to reject the null, not supporting alternative. Yeah, if you reject the null, you are accepting, supporting. We never really say, by the way, this is also, I saw this on the quizzes. I'm glad you asked this, Sarah, because she said you are accepting the alternative if you reject the null. Be careful with the verbiage. That's a trick on your multiple choice. You will never select accept the alternative. You will never select accept the alternative. I saw some of you selecting that, because technically, if you're rejecting the null, you're like, yeah, I'm accepting the alternative. We never use that in statistics. We never use those words. We always say sufficient evidence to support the alternative, you know, or statistic, you know, we're supporting the alternative. We never say we're accepting it. Okay, yeah. So I saw some of you selecting that, and that was on the multiple choice where you could like click more than one. And that's something else I want to talk about in a second, but you're clicking more than one that basically is correct. So some of you selected, I'm accepting the alternative because I'm rejecting a null. No, no. We're not doing that. We don't ever say that. That is a trick. Do not select accept the alternative. Do not. You go, am I supporting sufficient evidence? Do I have sufficient evidence? Do I have evidence to support the alternative, or am I not supporting the alternative? I'm never accepting it. Okay, cool. I like that. The making sense thing. So again, always and forever, if I reject the null, I have sufficient evidence to support the alternative. I'm allowed to support the alternative. I'm not accepting it. I'm supporting it statistically. Could be incorrect because there are type 1, type 2 errors, right? If I fail to reject the null, then there is insufficient evidence. I cannot support the alternative. Okay, good. And by the way, the p-value method will never change. If the p-value is less than or equal to alpha, we reject the null, period. I don't care what type of test it is. The p-value method is not dependent on the type of test. These inequality symbols will always stay the same. It's the traditional method that depends on the type of test because you're comparing the test statistic to the critical value, like its location. So if it's a left-tailed test, you know, then yeah, if my test statistic is smaller than my critical value, I would reject. It would be in the rejection region. That's why I said if it's in the rejection region. But Newton will say, since the test statistic is less than the critical value, then I fail to reject. But that's the same thing as saying it's not in the rejection region. So the traditional method, when you're comparing the test statistic to the critical value, that depends on the type of test. P-value method does not. This is standard. Does that make sense? I know there was confusion with that because you got 3 type of tests. You got, 2 methods and all that stuff. Oh, I got something else for you. You ready for the next thing? I want to stress this. And the reason I want to stress it is because there wasn't a whole lot of practice with this in the homework, but you saw it on a quiz and you could potentially see it on the final. And it's not difficult, I'll tell you this. You could indicate that this is what you're doing just based on the verbiage. If you need to write it down, meaning, I'll show you what I mean. Some of these select all that are true type of questions with the hypothesis testing, they got confusing because if you saw rejected, no, you're looking for sufficient evidence to support the alternative, and some of them were not there. You saw these funky things like, if blah, blah, blah were true, then there would be this percentage chance of this, blah, blah, blah. You saw these like weird worded things. So those were like hidden ways of asking you to interpret the p-value or the alpha. So how does that look? Because I want you to see how it looks. I'm going to make it simple, and I'm going to suggest that you write this down for yourself. I would even put this like interpreting p-value on my thing. I'm going to show you because at this point in time, if you go through trying to really, if you don't fully understand it, now it's just a matter of don't tell anybody, just get through this problem, right? Okay. So, I found these things online to indicate like what a p-value is. P-values indicate they gauge how consistent your sample statistics are with the null hypothesis. Specifically, if the null hypothesis is right, what is the probability of obtaining an effect at least as large as the one in your sample? The p-value is a probability, which is an area. It tells you how likely it is that your data could have occurred under the null hypothesis. Okay, so like I said, it tells you how often you would expect to see a test statistic as extreme or more extreme than the one calculated by your statistical test, blah. I know, so if your p-value is 0.05, this means that 5% of the time you would see a test statistic as least as extreme as the one you found if the null hypothesis was true. Okay, let's just make this easy. Let's make this much easier because I know that's a lot of stuff. If you see anything, so here's a random example I randomly made up based on another example. The lifespan of a turtle is 60 years with a population standard deviation of 40 years. I'm going to copy this stuff. I'm going to write down, the stuff that I get from this population standard deviation. 50 turtles were randomly sampled. Sounds like a sample size. To determine if the lifespan, that's an underline, if the looks like I'm crossing it out, to determine if the lifespan is less than the typical average. And, this sounds like a type of test. So I automatically, when I hear a claim or something, I go into my null, my alternative, and it sounds like it's a test or claim on an average. And I want to know if it's less. So that sounds like a left-tailed test, right? Okay, so this could be equal to or greater than, right? So we found the p-value. Look at the p-value was given to me. The p-value was given to me. And here's how I know that I'm going to be asked to be interpreting the p-value. And by the way, these are the ones that I saw some of you making errors on, what week was that? God, 14, 13, I don't know, whatever week it was, where you have to select more than one option. How do I know that it's asking me to interpret the p-value? So you could be asked to select more than one. And in this case, I would fail to reject the null hypothesis. But if you see something like this, if the population average lifespan of a turtle is 60 years, and if another 50 turtles were sampled, then there would be a block. Okay, I see the p-value here. Then there would be a 23.5% chance of less than 60 years average lifespan. So I see a p-value. If I see the p-value in percentage form, I'm going to try to find the one that goes with interpreting the p-value. Put it like that. Okay. So, and it always sounds like this too. If blah, 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 if this is true, and if another amount of sample and another amount of the same sample size were sampled, this is going to sound the same every time. Then there would be a p-value percentage chance of the alternative. So I go to the thing, it's asking me to select all that apply. I don't know, I'm rejecting or failing to reject the null hypothesis, and then I don't see sufficient or insufficient evidence. I don't see the ones where it's like supporting the alternative or not supporting the alternative. I see these other weirdly worded cases. If I see the p-value in percentage form, you're basically interpreting the p-value. You need the one that has the p-value in its proper percentage form, and then this should match the alternative. Okay, put it like that to make it nice and simple. And if it were me, I might even actually write this down, and you could literally just, if what was given to be true, another sample size, then p-value, percentage, and then alternative. You could literally write that down on your reference sheet to just to be able to give you an idea as to what you would be picking, if that makes sense. Just to make it real nice and easy. Does that make sense? Do those sound familiar to you? It's not as bad as you think. It sounds way worse. At the end of the day, pick the one. It's basically interpreting the p-value. Now, the other thing that I know that was funky was interpreting the alpha. And interpreting the alpha goes along with the type 1 error because alpha is the probability of a type 1 error. And this is a review. Type 1 error is rejecting the null when it is true. So you go to these things, and let me actually write this down again because I personally like to have this written. It's the same problem. Let me just rewrite this, 60, because I like to see that when I'm actually trying to interpret any of the errors. Okay, so how do I know? So I have the same words as the problem, and then I'm going to select all that apply, right? But this one doesn't have the p-value percentage here. It has a significance level percentage, put it like that. So now I am interpreting the alpha. And this, I think, is a little bit easier because I hope that you kind of already know how to word these errors. Because a type 1 error is rejecting the null when it is true. So for me, if I'm trying to interpret a type 1 error or an alpha, I'm looking for rejecting the null, start there. Rejection of this. So I'm supporting this, right? Conclude that the population average is less than. That's what I'm looking for. I'm supporting that because I'm rejecting the null. When it is wrong, when it is wrong, when in fact it is greater than or equal to. So I'm supporting, this is sloppy. Supporting the alternative when I shouldn't. Supporting the alternative when it is wrong or when I shouldn't. Okay? And the probability of that is alpha. So if I'm trying to interpret, put it like this, if I'm trying to interpret my p-value, I'm looking for this type of, verbiage where if this is true and I do more of these same sample sizes, then this p-value percentage would be of the alternative. If I'm interpreting an alpha, I'd be saying, so there's a 5% chance that's alpha. So I should be supporting the alternative less than 60 years when I shouldn't. And however you need to put that on your reference, even if you write this example down or example from your homework, just to have to look at, because the verbiage is going to sound extremely much the same, and that's not proper English, but you know what I mean. So I wanted to show you that because it is a possibility. It's not directly asking you to interpret the p-value or the alpha. It's asking you select all that are true. And you could be asked for, you could be asked for, since the p-value, let's practice that, is 0.235 and the alpha is 0.05, are you rejecting or failing to reject the null? In this case, my p-value is greater than alpha, right? My p-value is greater than alpha, failing to reject the null. And then you would say, failing to reject the null, not enough evidence to support the alternative. Okay, insufficient evidence. I'm gonna I'll clean that up after, to support the alternative. Blah, 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 which is, less than 60. If I see this, words that are not sufficient evidence, insufficient evidence, or supporting the alternative or not supporting the alternative, is it alpha or is it the p-value? So, questions about that? I wanted to stress that for a reason, because I know that there were some questions about that. I'm still going to do more examples. I know if you guys have to go, you have to go, but at the end, I'm going to do as much as I can. Tell me if I'm missing anything that you want me to do. So I want to do this one too, because I saw mistakes on this. And I want to say that we took this out of the final, but I want to also talk about it just in case. So let me see if I have this here. Minimum sample size required. I have to add to this. So you have, and technically, z of alpha over 2 squared times pq over me squared. So I should add another formula here just in case you see it. Technically, I think, like I said, I think we took it out, but I want to just say it just in case. I want you to know how to do this problem too, because I know that some had issues with minimum sample size. So how do I know it's minimum sample size? Let's start there. Suppose an internet marketing company wants to determine the current percentage of customers who click on ads on their smartphones. Now, my brain is going, they want to determine a percentage. I'm thinking I want to determine a P, because you have to think about whether you're dealing with a mean or a proportion sometimes, right? With these critical value confidence intervals. Let me just make sure. Okay, with these confidence intervals and hypothesis tests. Use a calculator to find how many customers, how many people, how many customers. That is indicating to find a minimum sample size. And when I'm asked to find a minimum sample size, I'm going to say, which formula is it? Is it the one that deals with sigma, or is it the one that deals with P? And if I'm dealing with percentage, I'm dealing with the P. At the end of the day, after that, everything is very much the same. Plug it into the formula. Either way, we still have to calculate a z-score. Sometimes you're given a z-score. Sometimes you're not. Now, I want to be 98% confident that the estimated proportion is within, that's my margin of error, within 5 percentage points. 5%, this is percentage points. So my margin of error is not 5, it's 5 percentage points, 0.05. So I want to find a minimum sample size required. And I have these two formulas. And Newton gave a lot of the situation where P and Q were unknown. And so we automatically put this down. Automatically put 0.5 and 0.5. I talked about this in my webinar. And so this formula simplified to 0.5 times 0.5, which is 0.25. Right? So the only thing that's not given to you is your z-score. But that part, actually, we just did, because of the fact that it's finding a z-score, an inverse norm, when I have a confidence level. So that middle area is my confidence level and my critical value that I want. The z-score is here, that positive one. So inverse norm, however you guys find it, 98. This one's 98%. I don't know, I put 90 like the last one. This should be 98%. Find it with me and see if you get the same thing. 0.98. I'm saying this is the area in the center because I have that option. It makes it a little bit easier. And then I can find my values. 2.326. And I think they tell you how to round the z-score if you're asked to find it. If they give it to you, they give it to you, I think, with 3 digits. And so at this point in time, I'm literally just plugging it in. Oops. 2.326 squared, 0.25 over 0.05 squared, right? So when they're asking you for how many customers, how many whatever, you're looking for your minimum sample size required, and you're basically between these two formulas. How do you know which one? Do they give you the population standard deviation? Put it like that, then you're going to use this one. If they don't, use the other one. And if you're thinking about it too, if you're dealing with a confidence interval for a proportion, you're automatically going to use this one. If you don't have the center option, again, you have to tell it the area to the left. You have to tell it this. So we know that if 98% is between these two, 100% is the whole thing, I have to have 2% split into the two areas. So you would be doing inverse norm. You would tell your calculator 0.99 because you have to tell it the area to the left. But you would get the same thing. So if you don't have the option to tell it the center, you have to, your calculator is automatically going to be thinking about the area to the left of the value that you want. Be careful how you input this formula into your calculator because you don't want to make the error of, basically doing all this and then, PEMDAS, your calculator does PEMDAS. So if you don't input it correctly, so I sometimes do this in pieces. If you don't input it correctly, then it might calculate things incorrectly, and then you get the wrong answer when you really use the correct formula. That would suck, right? So yeah, 541.03. We can never have a whole number. I mean, a piece of somebody. And so I see, Rosa, we always round up, right? Always round up. Okay, Angela, where did I lose you? Plugging it in?
Yes, so since I don't have the option for the center to tell it center, for my area, I'm gonna divide 0.25. Is that what you said?
No. So just be careful, when you're dealing with a confidence interval versus hypothesis testing. Every single time you do a confidence interval, you put the confidence level in the middle, and then whatever's left over on the ends. So the confidence level is 98%. So I have to, right? I have no choice but 2%, right, to split.
Okay.
So again, always when it's a confidence interval, right? You're going to do this. It's different with hypothesis testing. And then you always need to put the area to the left of the value that you want. So that's why sometimes I draw the picture because it makes it easier to see, hopefully, that you're going to deal with the 0.98 and the 0.01.
Okay, I'm going to try it really quickly and see, because I think this is what I had trouble on in the past in the quizzes.
Try it. Go ahead and try it. And we can, we can practice more of these too. I don't mind.
Okay, I did get it, but I got negative 2.3.
And you know what? Here's the thing, Angela. Like that's okay. The only thing is that you have to think about when it's positive and when it's negative. The reason you got negative is because you're finding this one, 0.01. If you put 0.01 in your calculator, that's fine. It's giving you this one. But at the end of the day, it's a symmetric curve. So you're going to get the same value. You're going to get the negative version. So just make it positive.
Okay.
But then that means that you have to know when you're doing what. When you're doing, like when you're doing what. When it's supposed to be negative, when it's supposed to be positive.
Okay.
Does that make sense?
Yes, thank you.
The 25, yeah. I put the 0.25 is because it's 0.5 times 0.5. Remember Newton did that over and over again? And I literally didn't even put in my formula, I put the 0.25 because that was the one you were seeing all the time. There are situations where, you might know the proportion. I think we took this out of the final, I have to be honest, because it wasn't practiced in the homework. Newton didn't have you see it. However, I'm showing it to you just in case, because if they do say, right, they give you all this stuff, it's a minimum sample size required, but they do say this last piece. What if the proportion is known to be 0.3? What is going to change? Your z-score will not change. Your margin of error will not change. This is what changes. You put that P here and the complement here. That's all that changes. If the proportion is known to be some value. And like I said, you know, I think we took it out, but I just want to just in case. So if you have that extra little, the proportion is known to be at the end, they're giving you this value here. And then this is the complement, 1 minus P. But everything else is the same. Let me see what I have here. Questions? Okay, now I do have more hypothesis tests. I have regression. I want to know what you guys, I have some confidence in. What do you want to practice again? Do you need regression? I know we just did regression last week, so maybe you're good with that. Do you need more hypothesis testing, confidence intervals? Tell me what we want to practice. Are you feeling more confident? Because I can do more stuff. I just want to make sure I cover what you feel. So like, you know, I wanted to cover these cases. We haven't seen them since week 8. You know, how do I determine that I'm using the central limit theorem? And then, you know, these special cases, interpreting the p-value, interpreting the alpha, the different things that you guys did with the p-value, the minimum sample size required. These are the mistakes that I saw a lot more of. Might do one of these as well, just because. I want to make sure that you guys know. I'm not gonna, well, I can't remember if you have any tables, but at the end of the day, like the table makes your life easier, so. For the thing we did last week, do we have to turn diagnostics every time? You know, if you go to your Lin-Reg equation and, you know, you go through the process and you don't get your correlation coefficient, then you have to turn it on. The diagnostics, turning that on just basically adds that leftover here that you need when you need the correlation coefficient. It should be on, but if you just don't see that, then turn it on. This one, I just want to talk about because of the fact that you have these symbols that that maybe, well, this is a confidence interval for P. Let me see. Determine the critical values. Type 1 error, type 2 error. I mean, we could do one of these. Let me see. Once I turn it on, yeah. So it should be good if you turned it on. Oops, you shouldn't have to turn it on again. But that's really what it's for. Do you guys need to practice a correlation coefficient one? Or the linear regression from last week? You know, I saw some people, and I think when you guys went to stat calc, Lin-Reg, or no, maybe it was in the stat plot, some people were putting, oh, this is what I saw. I'm trying to remember what I saw, these mistakes that I've seen. I think I saw people putting stuff in store reqq, And that was maybe giving errors. I think a few of you got errors with last week, right? So let me, I wish I didn't, I have a lot of, a lot of values here. Let's do this problem. And I'm going to show you maybe why you might have been getting errors and what you need to do. You don't have to do extra stuff, put it like that. Let's find the correlation coefficient. We'll find the regression equation. Maybe I'll make up a value and we'll predict and determine if it's reliable and reasonable. So, because that's really all you're doing with regression and, you know, the regression analysis and such. So hopefully this is linearly correlated. Let's look at the scatter plot and see if there's a correlation. So we have a list of values. We have two different types of situations. We have height and speed. The data on the maximum height in feet and top speed in miles per hour of the 14 roller coasters are given below. And we'll see if there's a linear correlation. We'll look at the scatter plot. We'll determine the correlation coefficient to see how strong it is. We'll find the regression equation, whether or not it's correlated, just for practice. And then we'll do some prediction just for practice, okay? From last week. So you have to think about, and typically this should be given to you, but you have to think about which one might be the independent and which one might be the dependent. And I'm going to say that height would be independent and speed would be dependent. So I'm going to put, you know, my height in L1 and my speed in L2, because I always like to know where I'm putting things. So I'm saying that speed is dependent on height of this roller coaster, because it makes sense to me that if it's taller, it would go faster, right? So let's see. Sorry, I put so many. Let's put these values in. Put them in there with me. Sometimes I pick these problems. I'm like, oh, I forgot to put it in prior. So now we're going to just do this together. Put all these values in. And then just make sure that you're not making it, you know, you just double check visually that you're not, you know, putting the wrong value in. Because one number can change your whole thing. So let's see, 230. I'm just going to put, how many do we have here? 208. So it looks like we have 14 data values. So I have to put another 14 in here. So I hope you have your calculators out because that's the way to do it. Practice. Practice, even though we're putting 14 values into L1 and L2. It happened. So let's copy this down. Hopefully I'm not making an error. I'm going to visually check this after to make sure. And I'll tell you a couple of reasons why you could potentially be getting an error just based on this part. So tell me when you guys have it down, because I know I'm not going to rush you because I want you to practice with me. So if you're watching the recording, you can always pause it. But if you're with me, I want you to practice with me. So let me know. And just double check your numbers. Make sure you didn't input anything incorrectly, because that could definitely change your whole thing. Cool. So we have these in. Now, one thing that can cause an error is if you have a different amount of numbers in L1 and L2. And sometimes that happens if you forget to like erase or clear out. Don't delete it, but clear the list. So sometimes if these don't match, your calculator's not going to make sense of it because it's supposed to be paired data. So that's one reason why you could potentially be getting an error. Okay, now let's practice graphing the scatter plot, you know, because you could be asked to pick the scatter plot. So every time you do a plot in statistics, you go to stat plot, and you're not really going to be doing anything crazy because, you know, we're not doing histograms, we're not doing box plot. All that is from the first, you know, half of the course. So it's literally just scatter plots. Okay, so mine is already on. If yours is not, make sure it's on, and then pick the scatter plot. My X list is L1, my Y list is L2, matching what I said here. So this already has what I need. Go, okay. Now, I saw someone also kind of going like, my graph is not working. This is not where your graph is going to be. This is you telling the calculator, this is where the information is, and this is the type of graph that I want. This is not where you're going to see the graph. This is just where you're telling your calculator what to do. Where you're going to see your graph is in graph. But if you click graph and you get an error, sometimes you might see like window dimension or WINDIM. Zoom stat that. Go to Zoom and Zoom stat. Same thing, like I'm not seeing my scatter plot. Go to Zoom and go down to number 9, Zoom stat. And what it'll do is it'll change your window so that it'll match your values. Any errors, anything, any problems? Another thing, and I'm going to show you this just in case, but if you ever play with the window, you might have, negatives. If you used, the subtraction symbol for negative instead of the negative symbol for your calculator, it's not going to understand the subtraction symbol as a negative. So that could be also another error message. Also, one other thing to check, go into your Y equals and see if there's anything here. I'm going to show you something. If there's something weird in here and I go to graph, it's going to give me an error because it's not understanding the syntax there. And I know you guys are not typically in Y equals, but if you're borrowing someone's calculator or you accidentally press buttons, some could accidentally go in there. So try and go into Y equals and make sure there's nothing in here. Clear out whatever's there. So that's another reason that you could potentially be getting a syntax error. Okay, so let me screenshot this. So it looks like I potentially have some linear correlation. Positive, right? Looks maybe positive, linear correlated. How strong it is, doesn't seem too great. I'll look at the correlation coefficient to support that. And I see you got that already, cool. So how do I get that? I'm going to stat and calc and then linreg. And here's another reason why some of you might have been getting an error message. I know that Newton has you go through a process where you're graphing the line on the graph. And honestly, you don't need that because you want the actual equation. If you want to see it, you can graph it if you want to see the line on your scatter plot. If you just want the values for your equation, you don't necessarily need to deal with that. You don't have to put anything in store rec EQ. Leave frequency list blank, store rec EQ blank, my X list L1, my Y list L2, and calculate. That could be another reason why you're getting an error message, because sometimes when you do like the store EQ, trying to store the equation, trying to graph it, like sometimes the calculator acts funny with that too. So your correlation coefficient is 0.88. Your equation, my slope, says round it to 2 decimal places, 0.13 x plus 54.52. And I'm going to look at this and say, well, it makes sense. Nice job. Yeah. No, good job. It makes sense because it looks like positive correlation. Looks like it's increasing. We're only measuring linear. Could be linear. My R is 0.88. And remember, the closer it is to +1, the stronger the positive linear correlation. So this looks like it's pretty strong, but not extremely, kind of what I would expect for this type of situation. And then my regression equation, be careful with your slope. My slope, I say always look at this little equation here because sometimes it's backwards. And the reason I say that is because if you go to number 4, if you look at it says ax plus b, that's kind of like slope intercept form. And the a is the slope. But if you accidentally or go down to number 8, you see that it says a plus bx, where b is the slope. So, you'll get the same thing, but you just have to be careful. Just make sure that you put in your slope as such. So like this says y equals ax plus b. So a is representing my slope based on the fact that I know slope-intercept form. My coefficient in front of x is the slope. So my a is 0.13, blah. Does that make sense? Now it makes sense that there would be some type of linear correlation, right? Because I figured, you know, the higher the height, the faster it is, right? So let's just say predict the speed of a roller coaster with a height of 500. Excuse me. Wow, Jackie. And then I want you to tell me, is it reliable? And is it reasonable? So when they're asking you to predict something, what really are they saying? Predict this. What are they saying? They're saying, take this, plug it in, right? So literally, I'm taking my predicted height, 0.13, my predicted speed based on that height of 500 into my equation. And sometimes they give you the equation and sometimes they don't, right? But not a big deal. My calculator really does everything for me. And 0.13, what do you guys get? Times 500 plus 54. Cool. Don't forget to add the 54.52. Altogether, the 119.52. And speed is what? Miles per hour? Miles per hour. Cool. So let me ask you, is it a reliable prediction? And tell me like why. If you're saying yes or no, why? Is it reliable? And you could
So,
type it if you.
yes, it's reliable.
Why do you say that? What are you looking
Because
for?
it's within our, isn't it the 119.52 is within our little, I'm trying to think how I remembered it for last week.
So when it's reliability,
It's reliable.
go ahead.
It's reliable because it's in between 190, 128 and 77.
Well, be careful with reliability and reasonability, if that makes sense. Which one do I look at the X for and which one do I look at the Y for? Yeah.
The
So-
119 is the Y form, right?
Yeah. So if basically to determine if it's reliable, is it in the domain? And when I'm talking about that, you know, I'm looking at this. This is the X value that they're giving me. Is it in the domain? The domain of the X values here. Is it within this? If it is, then it's reliable. If it's not, then it's unreliable.
So it's
When
unreliable.
it's unreliable. When it comes to reasonability, this is kind of like, does it make sense for the situation? Okay. It like, does it make sense for, you know, based on your outcomes, kind of. And you know, if it were like something like, you know, 300 miles per hour, which is like really far away from all these, I would say it's probably unreasonable. But being that this speed, 119.52, is kind of like around this range of the speeds that are given here, and it would make sense, you know, like if I have a higher height, I would expect a higher speed or speed on the higher side. I might say it's reasonable. So, Not necessarily is it in the interval, but does it make sense for the Y's? Yeah, it's the interpolation versus extrapolation. Technically, you can get away without knowing those terms. Just here, is it reliable versus reasonable? Yeah, but that's where it comes from. So, questions about that. You're not doing like anything crazy, you know, like that's last week, but you could be asked for any part of this, you know, predict, find the equation, find the correlation coefficient, you know, reasonable, reliable, any part of that. Now, you know, I want you to know that I did not do every single situation for hypothesis testing. I didn't do every single situation for confidence intervals, but you know, you let me know if you need another one of any of the others. Because I'm more so like gisting, right? Because you have 3 cases for both. You know, you have to determine, you know, is it a confidence interval for a population proportion, for a mean, is sigma known or unknown, or is it a hypothesis test? But at the end of the day, the rest of it is pretty much the same in terms of like how to interpret and how to come to your conclusion. But if you need to practice another one of those, let me know. I'm trying to think what else. Because obviously most of this is hypothesis testing, confidence intervals, but the stuff we hadn't seen for a while was, you know, finding these areas, finding these probabilities, using the central limit theorem. And then I know there were some mistakes with p-values, and there were mistakes with these interpreting p-value and interpreting alpha. And I saw syntax errors when it came to last week, and then minimum sample size required. So I have the gist here. You know, week 8, you had normal distribution, inverse norm, normal CDF, z-scores, central limit theorem. Week 9, you had confidence interval basics. Week 10, hypothesis testing. Week 11, hypothesis testing for mean with sigma known, type 1 and type 2 errors. Week 12, confidence intervals, hypothesis testing for mean, sigma unknown, student t-distribution. Week 13, confidence interval for proportion, minimum sample size required. Week 14, hypothesis testing for proportion. Week 15, linear correlation and regression. So talk to me about, this also had minimum sample size. Talk to me about like anything else that you might need to look at, or if you want to just go ahead and practice and then see if you have any other questions, you can let me know. Tell me if there's something else you want to see. I know it's getting late, that's why I'm kind of, because I have other questions here that we could do, but let me know what you guys need. Want to practice another hypothesis test? Or a confidence interval? Are you going to post? I'm going to post this video. I could post these notes too. Okay. All right. You guys feel a little more confident? Are you ready for, I'm going to say goodnight now. Yeah, I knew it was late. I'm going to stop recording. If you guys have another